Welcome to the final video for chapter 8 and the final video for year 2 applied. It's 8.5 integrating vectors. Okay, so in this video we'll be integrating rather than differentiating like we did in the last one. Okay, so this information, we've got this velocity given in I and j form. I'm going to write it as a column vector. We know that the integral of velocity is the displacement or the position. So in this case, r is going to be the integral of velocity. So let's do that. So we're going to have 3 over 2 squared. And this one's going to be 1 over 6t cubed. But remember, we have our constants here. I'm going to separate them. I'll call this constant for I, this constant for j. Okay, so if we separate them out, so we've got this information here at time t equals 0, the position is 2i minus 3. T equals 0, r is equal to 2 minus 3. Okay, so I can substitute that in. I'm going to do them separately here just to make it obvious what's going on. So I'm going to do the I vector first. Times by 0 plus ci. Okay, so we can see ci is equal to 2. And then we can do the same for the j part of the vector. So negative 3 is equal to a 6th times 0 cubed plus cj. Cj is equal to negative 3. So to find the position of the vector at time t equals seconds. So now we can just substitute those back in. So the position is equal to 3 over 2 t squared plus 2, the top one. Just extending this down a bit. 1 over 6 t cubed minus 3 for the j component, and that is in meters. Okay, so that's for example 8. Right, moving on to example 9. We've got an acceleration here. Let's rewrite that as a column vector. T equals 3. We've got, I'll write this across the top here. The position P, the velocity is equal to 6i, so it's 6, 0, and the position, we'll call this r, is equal to 23. Okay, so first of all, he wants the angle between the direction of motion of P. Okay, so in order to work out that angle, you need the vector of velocity. So velocity is the integral of A. So in this case, you've got 4t plus this c component, we call it ci, and then you're going to have minus 2t, increase it by 2, divide by 2, so it's minus t squared plus the j part of that c. Okay, so work them out. We're going to use this up here. So when t equals 3, v equals 6, 0. So I'm going to separate them. First do the I component. 4 times 3 plus Ci. Ci is equal to 6 minus 12, negative 6. Do the other one. 0. Negative 3 squared Cj. So that'll be equal to 9. So my formula for velocity is going to be equal to 4t minus 6 and minus t squared plus 9. I'm going to write it the other way around. And then it wants the direction of motion. Just going to fit it in down here at time equals 2. So time equals 2. Velocity is equal to 8 minus 6 for the top and 9 minus 4 for the bottom. Putting that into a little triangle, it's going 2 to the right, 5 up. It's heading in that direction, and it wants the angle with I. So this is I, so it's this angle here that we want. So alpha is equal to 10 to the minus 1 of 5 over 2. Put that into your calculator, you get an answer of 68.2 degrees. Okay, moving on. Let's get on to the second part here, part B. We want the distance between P and O when t is equal to 0. Okay, so O is obviously the origin, 0, 0. We've got the position vector when time is equal to 3. We need to work it out when time is equal to 0. So we need an equation for position, which is r. R is equal to the integral of v respect to t. So that will be the integral of this one down here. Make it bigger. So this will be 4 2t squared minus 6t plus, that's constant, and then this would be 9t minus t cubed over 3 plus the j component of the constant. We need to work them out separately. So we've got this information again that we can use. So the position is 23 when time is equal to 3. So do the top one first. 20 is equal to 2 times 3 squared minus 6 times 3 plus ci. That is 18. That's 18, so that's 0. So ci is equal to 20. And then do the second one, 3. And 9 times by 3 minus 3 cubed over 3 plus cj. 27 minus 9 is 18. Take that away from 3. Cj is negative 15. So we get R is equal to and those two together. And it wants it when time is equal to 0. Time is equal to 0. Well, it's P in this case, isn't it? Because that's where P is. So that's 0, 0, 20, 0, 0, negative 15. So the distance between them, so here is O. It's going to be 20 across 15 down, 20 across 15 down. So this is O, this is P. What's this direct distance? So OP is equal square root of 20 squared plus 15 squared, which is 25 meters. Just about fitted it on the bottom there. And that is it. Example 9.